Let's evaluate the limit as x approaches 0 of x squared times sine of 1 over x. Now we're going to use squeeze theorem to solve this problem. And let me remind you what squeeze theorem says. It says that we have three functions: f of x, which is less than or equal to g of x, which in turn is less than or equal to h of x. And this is true for some interval. So for the entire interval, it could be the entire real line, doesn't have to be, just some interval from, let's say, -1 to 1 or -3 to 3, depending on the situation. And limit as x approaches a of the smaller function f of x, let's say that limit equals L. And that also happens to be the limit as x approaches a of the biggest function h of x. So both of those are equal to L, and this x equals a is inside the interval for which this statement right here is true. Then the conclusion is the limit as x approaches a of the middle function g of x is squeezed in between. Since it's squeezed between the two and both of these go to L, this is forced to go to L as well. That's what squeeze theorem says. Now also recall that whenever we have a sine function of anything, and particularly say in this case we have sine of 1 over x, no matter what value of x we put in there, it can never be bigger than 1. So sine of 1 over x is between +1, less than or equal to +1, and also it can't be any less than -1, so it's greater than or equal to -1. So x squared times sine of 1 over x is less than or equal to x squared times 1, and then greater or equal to x squared times -1. This will help us greatly to solve this problem. Let's write this inequality once again. X squared times sine of 1 over x is less than or equal to x squared and greater than or equal to -x squared. Now let's apply the limit. Limit as x goes to 0 of -x squared is less than or equal to limit as x goes to 0 of x squared times sine of 1 over x. And that's less than or equal to the limit as x goes to 0 of x squared. Now this limit I'm circling here, and this limit I'm circling over here. Both of these go to 0. And by the squeeze theorem, the limit in the middle, that is the limit we are evaluating, is forced to go to 0. So the answer is limit as x goes to 0 of x squared times sine of 1 over x is equal to 0. Now graphically, we can, if you have a graphing utility, you can graph these functions. We have x squared, which is this parabola, negative x squared, which is a parabola that opens down with vertex at the origin, and then sine of 1 over x. It kind of looks like this. It's always between these two functions. So it sort of does that. The sine wave, not exactly like the regular sine, but it approaches 0 from this side, and then from the top there, it does the same thing. It's always in between these functions. No matter how we approach 0 from the left or from the right, the graph of x squared sine of 1 over x heads to 0, and that's the limit. For more videos, go to www.mathprepvideos.com.